Hello everyone, in this plugin script tutorial I'm going to show you how to write a Unison oscillator in which the beat frequency determined by the offset of the oscillator's frequencies always equals a tempo sync step like 1/4, 1/8, 1/16 or 1/32. But before jumping into the code, I just want to show you how it sounds. Now what I really like about this sound is that it feels different on different frequencies. That might not make a lot of a difference between 2 and 420 Hz yet. The reason why I didn't choose the full spectrum here is because plugin script doesn't offer you the feature of making skewed parameters. So you can't really make a good frequency parameter in this framework unless you restrict yourself to very small ranges like this. But if we were to try really high frequencies, then we wouldn't hear the frequency offset a lot anymore because humans don't perceive a difference in frequency as much in the higher parts of the spectrum as they do in the lower parts, and that becomes more apparent when the beat frequency is very strong, because the stronger it is, the further apart the frequencies are. But the funny thing is we still hear the beat frequency very clearly, even though we don't hear the offset in pitch anymore. So let's actually try that now and go to some very high frequency instead, and that might create a sound very soon that is not very pleasant, but I will do that anyway for the sake of science. So as you can hear, you could not really hear a difference in pitch or anything like that anymore, even though you could still hear that on the very low frequencies, but you could still clearly hear the beat frequency, and that's what makes this so exciting. Now let's jump into the code so that you can actually see how this works. I also link to it in the description because it will be part of my plugin script repository, PNS Fundgrube, where I put all my favorite scripts that I write in AngelScript. This one is particularly easy actually. We have three parameters: frequency, amplitude, and beat. Frequency in hertz, beat in decibels, and beat just has this beat string. As member variables, you just need two phasors so that you can make oscillators from that later. A phasor in my plugin script stuff is defined as this class. It just has the buffer where it puts the phasor in for each block, and then it does this for each sample. Basically, this creates a phase. If you're not familiar with the concept, it is basically like a saw wave that moves between 0 and 1 in a certain frequency defined by the increment value. We need to find a way to calculate increment values in a way that it fits to the requirements of this project. I'm getting the frequency in hertz from the first parameter, and I'm getting the first increment value by just saying frequency hertz divided by sample rate. So the first frequency is easy. Now we have to find the offset, and we know that the beat frequency of a Unison oscillator is defined by subtracting one frequency from the other. So we need to find a value for that that corresponds to a certain time in beats. So we get the BPM from the transport information of the DAW, and we calculate something about, or actually I should have called this BPS because it's like beats per second. Then we get the parameter with the information about the beat frequency, and we are renting that so that there are only integer values. And then we have to use this calculation on that so that we get the value that we can then multiply with the beats per second in order to get the frequency offset. As you can see, I'm outputting here what these values look like. On the fourth note, it equals 1, so that no change is applied. Then on 2, it is like twice as fast. 4 is 4 times that fast, and then 8. So that's how you deal familiar with beat type parameters a lot of times, not just in this example, but this is just a reoccurring pattern. Now that you know the frequency offset, you can just go frequency hertz plus frequency offset and then divide by sample rate again, just like with the phasor before. And now you can process the two phasors. Then you get the parameter for the gain. I didn't bother with parameter smoothing or anything like that for this simple example. I just went straight into the channel loop and into the sample loop. Then I said, yeah, make me an oscillator for phasor 1 and oscillator for phasor 2, add them together and then multiply with gain and with 0.5 so that 100% gain does not exceed 0 decibels because we have two oscillators obviously. And that is all you need to know if you want to make an oscillator where the unison offset of the frequency always creates a certain beat frequency in relation to the project BPM.